My name is Ibrahima, and I'm really happy to be here today to talk about this topic. So just before starting, I would like to thank Adam for inviting me, of course. Adam and his staff. He is doing amazing things for this community. So a round of applause for him, please. Yeah, and I like to thank as well the developer community in Senegal. They are sending me a lot of love for this talk. All right, so without any further ado, let's get started. So what are we talking today? I'm going to show some slides about some concept, demystifying some jargon. And we are going to do some live coding, right? Yeah, and I do hope that Xcode don't disappoint me. A few other slides and a wrap up. Okay, so for the demystification, I talk about modularization and monolith, but what I say? So for modularization, it is just a software design technique that lets us separate our app feature into many smaller independent modules. Independent, it is really important, right? And what about a monolith? So a monolith is just an app where the application is a single unit, which means that all the business logic is on one place, and if a change is applied to the app, chances are it affects the whole app, okay? So next we are going to see the anatomy of a monolith app. It looks like this, okay? Where you have everything that kind of linked together, okay? You can have really nice folder structure and so on, but when it is a monolith app, everything is kind of related, okay? Feature A can talk to feature B, can talk to the network layer, the models, and so on, okay? Right. So this is kind of problematic because in an ever-growing code base, scalability and readability and overall code quality often decrease over time, right? So this comes as a result of the code base increasing in size, without its maintainer taking active measure, okay, to enforce an easily maintainable structure. Now, let's talk about some advantages and drawbacks about monolith, okay? So for the first advantages, we have the simplicity of development and debugging. Since the code is bundled up, everything is talking to everything. It is quite simple to navigate and debug. Simplicity in onboarding new team members as well. It is not, since we don't have separate modules, a new team member can focus on the structure of the app and find their way around. We have low cost in the early stage of the application because once you begin to develop an app, probably you want to have a V1 as quick as possible. So going into a monolith will help you achieve that very quickly. You don't need to think about separating your app and so on, because at the end of the day, everything we do it for the user, right? And now for the drawbacks, okay? So we have definitely a highly coupled code. Like the slide I showed you, everything is talking to everything. We have slow speed of development, since when the app is going to grow, you are going to decrease in performance and productivity. longer build time when the app grows. And it is perfectly normal because you are adding more and more feature. And testing becomes a little bit harder because once you start to test a feature, chances are that feature will talk to another feature, and you can't test directly in isolation. And last but not least, the barrier to adopting new technologies. Okay? Okay, now let's talk about the modularization, the wins of the modularization. So the first win, we have the reusability. Like, think of it like the slide I show you, where we have the separate layers. For instance, when we take the networking module, the networking layer, we can extract that into a package, okay, that we can reuse on the upcoming project again and again. It forces us strict visibility control. What I mean by that is you have to think about the boundaries of your packages, right? Like feature A should not talk to feature B, so you should enforce your class and struct visibility control. Customizable delivery. So since you are working on a modular app, you can, let's say, your team, one of your team members can work on feature A, another one on feature B, and they deliver it, which increase the developer productivity, the team productivity overall. And we have build time improvement as well, because when you focus on just one feature, let's say, you don't need to think about building the whole app. So your package will be really fast to build. And testability, it makes the code more testable since you are working in isolation. Okay. Parallel development, I talk about it. So a team member can work on feature A, another one on feature B, another one on feature C, and so on. And community support. Like the networking layer, you can push it to GitHub and receive some feedbacks from the community, helping you fix a bug, improve performance, and so on. But we have some drawbacks as well, right? The first one is too fine-grained, okay? Because every module brings a certain amount of overhead in the form of increased build complexity and boilerplate code, okay? A complex build configuration make it really difficult to keep configuration consistent across modules. Too coarse-grained. So if your modules are growing too large, you might end up with another monolith application and miss the benefits that modularity has to offer, right? And it can be complex as well, okay? It doesn't always make sense to modularize your project. A dominating factor is the size of the code base. So if you don't expect your project to grow beyond a certain threshold, the scalability and build time gain won't apply that much, okay? And after that, we have some tips that that will help you to have a modular app. Even if it's not a modular, those are some tips you can apply even with a monolith app. So the first tip is to try to respect the solid principle, okay? And single responsibility and so on. And if there is just one principle out of these 5 you should try to respect every time is a single responsibility, okay? Because it is going to force you to think about the responsibility of your class or your struct in order to not have dependency between your class or struct. The second one is dependency injection, okay? It is just a fancy term. It is really easy to grasp. Dependency injection is here to help us write loosely coupled code. And I do have a video to show you to illustrate that. I don't know if it is going to play. Okay. Okay, this is my daughter trying to trying to play radioactive.
Wake up by Delicate and Nando now playing.
Hey Siri, play radioactive.
Here's Radioactive by Magic Dragons. Hi there. By the way, it's 6:08.
She changed her mind.
Wake up! It's 6:08.
All right. So why I show you that? For dependency injection. It is just to illustrate that talking to Siri is not her responsibility, okay? Because when she talks to Siri, when she talks to Siri, she might get another result, right? And it is my responsibility to talk to Siri in order to have what she wants, okay? Her responsibility is just to slap at me, to disturb me when I'm trying to focus, right? Okay, and it is the same thing as a dependency injection. So if you have a class or struct or anything that try to do everything, you might end up having a coupled code, okay? And it is not what we want, right? Okay. So for the next tip, try to apply some design pattern whenever possible, like the factory pattern, the facade, mediator, and so on, okay? Some tools we can use to modularize our app. We have frameworks, static or dynamic. We can create directly from Xcode. We have some dependency management tool like CocoaPods and Cottage. And our favorite one, obviously, Swift Package Manager, which is baked by Apple and have a great integration with Xcode. Right. So some modularization technique. We have layer modularization, where you extract some part of your code, like the networking layer, your models, storage, and so on. This is cool. But you want to gain some performance boost with it, okay? Even it is really great to extract all these modules into packages. Next step, you have feature modularization, where you try to extract the main features of your application into modules, right? Okay. And you can have a mix of both, okay, with layer and feature modularization. And this is best, okay? This is the best because you are going to gain in performance boost with build time and reusability as well. Oh, let's code now, right? Okay. So I do have here an app. Let me just switch. Mirror. Okay. Okay. So I do have an app here. Can you see? Okay. I'm going to run the project. It is just an app to show you the movie, and it seems like there is no internet connectivity, which is a bummer. No problem, no problem. No problem, but you should see it is shimmering, okay? You should just see the movie if we had internet connectivity, but it's not the point. It's not the point, but what you can see here, let me just, okay. What we can see here is that we have this kind of, it is a monolith app first, okay? We have this kind of organization, right? With the feature, the app, the modules, and so on, okay? And yeah, we don't have that much problem. The app is building really fast, but imagine that the app gets, we add some new features to the app. So the build time is going to decrease drastically. Now what I'm going to do is I'm going to switch branch, git. Okay, so, okay. Modularization, phase 1. Let's see that. Let me build the field, okay, no problem. Yes, Xcode, right? But the point is, here, I just want to show you the organization of the project with modularization phase 1. Here we go, okay? So we have some packages, some Xcode packages, okay? We have a shared one, and inside the module folder, we have some modules, okay? And those are the layer modules, like the core, the networking, utils, storage. You might throw other modules that are relevant to your project. And we have the feature folder with 3 packages: media feature, movie, and series feature. So with Xcode, what you can actually do is that you can have a package with multiple targets, okay? Or you can have one package and one target per package, because the package comes by default with one target, okay? Let's go to the modularization phase 2 now and see that. Okay, let's see if it is going to build. Yeah, build it successfully, right? Okay, let me actually show you the structure. Okay. Okay. So now we have only 3 packages, right? And inside those packages, okay, we have several targets, okay? We have a feature package, a core package, and a shared one. Let's see the feature package, the manifest file of the feature package, okay? So it looks like this. Can you see the screen well? Let me zoom a little bit, okay? So it has, here is the manifest for the feature package. So here, we define the products, okay? We say that we need a media feature, movie feature, and series feature. We define the dependency, okay, that we are going to need for this feature. And we define the target. Like I said, we can have multiple targets in one package, okay? So here I define 3 targets: media feature, movie feature with its dependency, and series feature with its dependency as well, okay? Once you go to core, it is almost the same, okay? So you have here the different targets, the utils, domain, storage, network, and you will find them here, okay? So you can, just to choose one, okay, one target, build, and you see that the build time is extremely fast. You can, once you start to modularize an app like this, control 0 will be your best friend, okay? Control 0 to pop up this, this target pop-up. And actually, you can just search, okay? Type in directly, Siri feature, boom, enter, command B, build, okay? And it is successful. Control 0 to pop up again, and you go to the main target, okay? So the main application target is just a composition of all of these packages, like we have here. So it is a composition of the app feature, like media. Let me actually zoom in. Okay, it is just a composition of the features we have inside our app. The media feature, the movie feature, and the series feature. Okay, series is just TV show. And those features are going to import the core library, okay? Like the networking, storage, and stuff like that, okay? Now, but, okay, let me just build and run. We have some errors as well, no problem. I have 3 branches, man. Let me switch. Git. All right, phase 3. Okay, I need to stash maybe before that. Okay, and if I stash, yeah, it is going to work before phase 3. Okay. No internet connectivity, no problem. But the point is here, okay, here is the app. We have the movie, the TV show, and the watch list, okay, which is just empty. But once you click on a card, it is supposed to redirect you on in a separate view where you can see the detail of the movie. And the point here I will like to show you is the features. Okay. Normally, you shouldn't have here, you shouldn't have a feature that is linked with another feature. This is called cyclic dependency, okay? But look at here. The movie feature has a dependency of media feature. And the series feature has also a dependency of media feature. This is a red flag, okay? Once your feature begin to link to each other, this is not good actually, okay? So you need to find a way to make those features work independently, right? Okay, so let's go to quickly to phase 3. Okay. All right. So what you can do, okay, it is successful. All right, okay. So what we can do here is to use one design pattern like the mediator. Why in the previous branch it was linked together was because of navigation. Because once you tap on a card in movie feature or series feature, it will redirect you to media feature, okay, into another view. So you need to decouple the navigation in order to have those features working independently, okay? And to do that, you will need a mediator, which is just another object sitting above the 2 features and giving those informations. So we have it here in the shared feature. Okay, we have navigation. okay? And inside navigation, it is really simple, actually. It is just a router, okay, where you can register your view, and you say to the, let me switch to the Siri view, maybe. Yeah, okay? So it is just a navigation link, okay? And you say to the router to resolve the path for the media details, okay? So it doesn't know anything about the view, okay? You need just to register that view in the root application, okay? For that, so that the application knows exactly how to find this, this view, okay? Not that difficult. And if we run the app, it is working, okay? But now we have the feature that are decoupled, okay? Here we don't have any dependency to the, how it called, the detail feature. Movie feature has no dependency to another feature, media feature as well, okay? So, with that said, I said that the main benefit of organizing your project like this is that you can build mini applications based on your application, based on your feature, and we are going to do that. I'm going to create a new application called new project or new target. I don't know. Yeah, it is new target. Yes. So I want a new project, a new app. Okay. I'm going to call it. Let me see. Movie app minion. Okay. Movie app minion, which is just a minion app, a mini app based on the movie feature. All right, here it is, okay? And what I can do here is, for the dependency, I just add as dependency the movie feature, okay? And perhaps the movie detail feature, okay? Movie details, right? Boom, okay? And here, so first, let's run the movie app minion. Okay, it is a simple Hello World app, Swift UI Hello World app, right? Now let's take it further. So here, I'm just going to pass some code. All right, so I just import the movie feature, the media feature as well. Let me see if here I need to import it as well, media feature. Okay, boom. And it is building. Now let's run it to see if it is going to work. And just like that, we have a minion app, right? That is only focused on one feature. So imagine how cool it is, because your team member can work on the TV show feature, run it inside an app, and deliver it for the QA team to test things and so on. And you won't need to build the whole app, the whole application. Okay, that is the power of actually modularizing your application. Okay, so back to the slide now. Okay, so some things you need to pay attention to. Cyclic dependencies, like we saw with the navigation. Okay, this occur mostly when you refer to a class in another module. We have large growing modules, which can be problematic because When you have large growing modules, those modules can turn into a monolith, okay? And you will have increased build time and so on. And you need to watch out the number of your modules, because when you have many modules, it will impact the size, the launch time of your application, of the main application. Okay, so to solve this, you can turn your package into a static library. But when you do that, you will have a more larger application binary. So you need to evaluate if it is good for you. And yeah, so what do you learn today? The difference between a monolithic and a multi-package app, right? The advantage and the drawbacks of both. How to use SPIM to create a package. Common issue when modularizing an app. And how to run a feature independently as a micro application, right? But the question is, should you modularize your application? What do you think, guys? Yes? No? Yes. Really? It depends, right? Yeah, it depends. If you are working solo, okay, or maybe you are an indie application and you don't need, and you need to go faster, like release new build really fast, maybe it is not the right tool for you, actually. Where I see this big jump in productivity when modularizing your application is when you're working on a team. You have you have to work on different features, okay? And that way, you can modularization can be really beneficial for you because you are going to maybe develop the features in isolation. So it will be a boost, okay, in productivity. But it depends on you. So that is my contact. I blog at isis.dev. You can follow me on Twitter. I do some consultancy, currently free, available. And yeah, thank you for your attention, and I'm looking for your questions.
All right. Awesome. Awesome. By the way, I am actually watching the talk backstage. Like, really awesome, Ibrahima. So questions, we only have about 4 minutes, so I'll try and rattle through some. We've got from Adam, great talk. What is the name? I knew this question was going to come because I was thinking the same. What is the name of the app you use to zoom into sections of your talk? The most important.
It is called Snipose. Here it is.
There you go. Is it free?
No.
Okay, of course. I mean, it's a Mac app.
You got to support indie developers, right?
That's true. That is very true. Yeah. Okay. If the modules are imported when building the app, how is the build time different?
Yeah, this is a really good question. Okay, so when we say that the build time is different is when you work inside a package, actually, okay? Because when you have the main target importing all those projects, the build time can differ, okay? It really can differ. It can differ drastically because you have some live dependency. Maybe you are hitting the network and so on. But when we say the build time is quicker, it is when you focus on one feature, like you work in pure isolation inside the series feature, for instance, because it won't need to import other parts of your project.
Cool. Perfect. This one's been upvoted many times, and I thought it would. Can't tempt us with the fact about height and not tell us Ibrahima's height. So Ibrahim is 2 meters and 3 centimeters, right?
Yes.
Yeah.
Yes.
Yeah, very tall. Any questions in the audience?
Great talk, and kudos for doing live coding in your first conference. That's great.
Thank you.
Fantastic stuff. You talked a little bit about the number of modules affecting app launch time.
Yep.
Have you got any experience in how scalable you found Swift Package Manager and Xcode when you are building the entire app within Xcode as opposed to...
Yeah, it used to be laggy on previous Xcode version, like Xcode 12 and 13. Previews just crashed and so on. But most of those problems are resolved now. So it is quick, it is really quick, really fast to build your packages with Xcode.
Cool, thank you very much.
All right.
I was wondering if I see you have navigation routes stringified. Is that because having a larger enum or something would make it cyclic? Do you have a way to have compile time guarantees that a navigation route will be registered and available?
Yeah, so what do you need? Maybe let me actually show that. Yeah, it is right here, okay? So you need to, why I do use a router is because I was working in iOS 15. The new navigation API wasn't available, obviously. So all you need to do is maybe build this, this navigation route. You can build it differently, but you need to register them at the entry level, okay? So that the whole application know about your different navigation and their views. Does that answer your question?
It was mostly that if you, for example, had a typo or removed it. Or
Yeah, this is one drawback of using strings. Obviously, you can make some typo and so on. I could probably use a enum, but yeah, I was just using something that worked quickly. Yeah, I built this overnight, so.
Good job. Thank
Yeah.
Don't want to fall.
What's the issue?
Yeah, okay, we're going to break up, but there's a few things, like someone said, really good talk. Doesn't seem like your first one. Who is taller, Antoine or Ibrahima? Ibrahima with the zoom and enhanced skills. There's loads of other talks, which I'm sure we'll pass on, and maybe Ibrahima can answer them.
All right,
Slack.
yeah, you can just contact me on Twitter and keep the conversation going there.
Perfect.